Alright, let's get started with another MySQL class. In today's class, we're going to talk about joins, right? Joins are one of the most searched topics about MySQL and databases in general, because with joins, you can retrieve data from multiple tables, right? In many ways. So you can see right here in this picture that I'm showing you right now, the types of joins. There are a couple more types of joins, but here you have the 5 main types of joins. Okay, inner join, left join, right join, full outer join, and cross join. This picture right here makes it easier to remember which one makes what. Okay. You can use this picture to remember. You can close your eyes and think about inner joins, and in the moment you think about inner joins, you can see this image in your mind. Same thing to left joins, to right joins, full outer joins, and cross joins, right? If you visualize these diagrams in your mind when you come to joins, when you talk about joins, when you need to use joins, it will be much more easier for you to remember what type does what and which one of them you are going to use. Okay, it's pretty simple. It may seem a little bit complex because we are dealing with multiple tables and multiple data that are referenced between these tables, right? So it may seem a little bit complex, but with this picture right here, everything becomes easier. I'm not saying that it's easy, but it's easier with this picture. Okay, so inner joins combine the rows from 2 or more tables where the join condition is met. All right, so the data you are trying to retrieve is going to be in this intersection between the tables, right? Left join, same thing, but the table 1 will also appear in your results. The data from the table 1, it will also appear in the retrieving output. Okay, so we can see that left join returns all rows from the left table, and matching rows from the right table. Okay, all of the left, the table 1, and the matching rows from the right, that will appear in this intersection here. Okay, the right join, the same thing, but from right to left, right? Returns all the rows from the right table and the matching rows from the left table. The full outer join combines the results of left and right joins. Here in MySQL, we will probably use the union operator to do this, but don't worry, you're going to understand it in the future in this class. And the cross join, in my opinion, is the most difficult to understand, but once you understand, it gets easier. It gets easy. This type of join produces a Cartesian product with the data that you're retrieving. Okay, it pairs every row in the first table with every row in the second table. Okay, we might be a little bit theoretical now, but when you apply this to answer questions, to retrieve data that has meaning, right? It will be clear. Okay, so let's move on. Let's start writing statements that retrieve data using the joins. The first thing we need to do before using the joins, I believe we have to create more tables, right? Because our database right here only has 2 tables, and that's okay. These tables were useful for us to understand how to normalize data in the last class, how to take a duplicated data from one table and store into another, and then reference this data that now is stored in another table in our old table, okay, in the table that this data was taken from. So just with 2 tables, I believe we will not see the real power of the joins. Okay, so let's create another ones. Let's get things more complex, okay, for you to evolve, for you to take another step in your journey, leveling up your knowledge in MySQL. Okay, so we already have the tables authors and books. Let's suppose that now I want to bring another entity to this game. I want to store the publishers, right? Because we don't know who are the publishers of our books, the companies that published our books, and the publishers. So as the authors are a separate entity, an individual entity. Okay, so let's create the table publishers. So create table publishers. Let's give an ID, int auto increment primary key. Don't worry about auto increment and primary key. You're going to understand it in the future. Let's give the name of these publishers. So char 255 not new. Okay, as we did in the authors table with the authors table. All right, so let's run this, and there you go. We have our publishers table. Can you see that? Now we have 3 tables. But we have a new problem here. We need to reference the publishers table to the books table, right? As we did in the books table, that we took the author and stored the authors in an individual table, and then we referenced the authors from the table authors in the column author in the books table. We supposedly, I don't know how to say it in English, but we supposed to do the same thing here, right? But no, because we just did what we did in the last class with the authors table and the books table, because that relation is one to many, many to one in this case. One author could write many books, right? One book could not be written by many authors. That was the model that we worked with, right? So many authors could write many books, but one book only could have been written by one author. In this case, the publishers is different. In the publishers, the relation between the books and the publishers is different. One publisher can publish many books, and many books can be published by many publishers, right? They can repeat. Yeah? So the same book can be published by many publishers. So in this case, we have a different type of relationship between the tables that we call many to many, right? Don't worry, we are going to get to details by the end of this course. We're going to design a full database from scratch with multiple tables, multiple relationships, multiple references, and we are going to write multiple queries to do multiple operations. All right, so don't worry, we're going to dive deeper into these concepts. But for now, you just need to understand that if you want to relate the books with the publishers, we need to have a relationship table, okay? Because the same book can be published by many publishers, and many publishers can publish many books, okay? So we create a table where we reference the ID of the book and the ID of the publishers. Simple as that, okay? We don't really need to have a table with data about the publisher to have a relationship between them. We don't really need to have a table about the book to have a relationship between them, right? So we can just have a table. We already have the books table, the publishers table. So we don't need to have columns. Sorry, I expressed myself in a bad way. Let me repeat it. You don't really need to have a column to give the relationship between the books and the publishers. You need to have a table that references the books and the publishers. All right, so let's create this table. So create table book publishers, right? Here we're going to create a column called book ID int and publisher ID int. We are just referencing the IDs of each one, and this object together represents the relationship between them, right? It means that this publisher published this book, And when we insert many records, we can repeat the same book published but by another publisher. Can you get it? So that's how you say, that's how you do, that's how you create a many-to-many relationship. Let's add the primary key. We need to have a primary key, book ID. In fact, as this is a many-to-many relationship table, the primary key will be both of the IDs. All right. So book ID and publisher ID. There you go. And both of them also are foreign keys, as I told you in the last class, right? Because we are referencing from other tables. So foreign key, book ID, references. We're going to reference the table books and the column ID, right? So we are telling that this column right here is a reference to a column that is in another table. All right. Here we're going to do the same thing with the publisher. So foreign key, publisher ID, references, publishers ID, That's it, right? This this column right here and this column right here. So this will be our many-to-many relationship table that creates the relationship between the books and the publishers, right? Let me run this statement and let's see our new table. Book publishers. There you go. Just two columns. We are going to populate this with the IDs of the books and the publishers to tell which publisher published which book. Okay? And for now, we are not using joins yet. We are just creating many tables and we are going to populate with many records for us to have a field that we can explore to understand the joins. Okay, so keep it up with me and let's continue this class. Okay, so now let's insert data in our tables, because we created new tables and these tables are empty. So this way we cannot use the joins, right? We cannot explore the joins. So let me think and let me get some data here. I'm gonna pause this video and gather some data for us to insert. All right, searched here, just searched here some publishers, right? Probably they're not the real publishers of the books that we have in our database, but it doesn't matter. It's just for educational purposes, right? So let's insert into publishers, publishers name, values, is that wrong? Insert into publishers, publishers is right. Okay, Uh, there's a publisher here that is called Bloomsbury. Another that is called Harper Collins, right? And another called Bantam Books. Okay, so let's insert into publishers name, right? Because the ID is auto increment and the values are these. We're going to insert the three at once. So let's do this and let's select all from publishers to see if it worked, and it worked. All right, now we have to insert the relationship between the books and the publishers, right? So in our book publishers table, we are going to insert the ID of a publisher and the ID of a book, and that will represent the relationship between them. Okay, so we have three publishers and we have nine books, right? Even with the books, with some of them being repeated. So just for educational purposes, let's insert the relationship randomly. Okay, let's pretend that we know what publisher published each book and insert this relationship. So insert into book publishers. In this case, we have to insert the book ID and the publisher ID, right? Book ID and publisher ID. We're going to store the following values. So the book 1 was published by the publisher 1, right? The book 2 was published also by the publisher 1. The book 3 was published by the publisher 3. The book 4 was published by the publisher 2. Okay. We have 9 books, right? Let's insert just these first 4 books. So book publishers, insert into books, but I'm sorry, I made a mistake here. The table is book publishers and not books publishers. Sorry. So there you go. Now we have our query run successfully, and let's see if our book publishers, that is the table that has the relationship between them, has the data in. There you go. Right? We have the relationship between the books. This right here represents who published what, right? So the book 4 in our table books was published by the publisher 2 in our table publishers. Okay, right here you cannot see the meaning of this relationship, because you was the person that inserted, right? And the idea of the books, but you can't interpret it. this data if you don't know the name of the book and the name of the publisher, right? So you have to know how to use joins, because with joins you can retrieve based, pay attention, based on these IDs, based on this relationship table that relates one book to a publisher by its IDs, right? You can retrieve the name of each one. In fact, you can retrieve any data from each one based on this. Okay? And that's why you need to know how to use joins, right? So now let's start exploring the joins. So let's begin answering some questions using the joins, right? So let's suppose that we want to answer the question, which books were written by each author and how much do they cost? Okay, let's suppose we need to retrieve a group of data that answers this question. Which books were written by each author and how much do they cost, right? So we have informations, data in this case, about the book, about the books. We have information about the author, and we need to join these two tables, right? So let's use the inner join, right? Because we need to retrieve data about the book and the author, but the author is not in the same table that the data about the book is stored, right? So let's write the statement, the query that represents this. So select books dot title as book. Okay, this book right here will be the alias for the book title, and let's select the authors dot name as author. All right, author. So this way we have an alias for the book, that is the name of the book. We have an alias for the author, that is the name of the author. And let's get the price too. Okay, books dot price. I believe the price we don't need to give an alias. Okay, so let's do it from books. There you go. But now we need to join this table. We need to join this table with the authors table, right? Because we have the books table selected, but we still don't have the author's name selected. We just have the alias, right? We just have the alias of the author. So we need to make an inner join authors on. What is the comparison we need to do? We need to get the books.author, yeah, the column author in the books column, and it must be equals to the authors the table authors, the column ID, right? So the table, the column author in the table books has to be equal to the ID column in the authors table. Okay, that's how we find the same author. And as we're joining the tables and giving an alias to the name of the author, this just works because we are using joins, right? This only works because we are using joins. So let's run, and there you go. We have an output that shows the name of the book as book, the author of that book, but not the ID of the author, the name of the author. If we didn't use join, the inner join specifically, from books, you would have the author, but you would have the ID of the author. So with inner join, we can go to the table authors, compare the ID of the author with the ID of the author that is referenced in the books table, and get their names, right? Simple as that. It may seem a little bit complex, but it's pretty simple, okay? That's how inner join works. So you can see here in this example, we are getting the intersection of the tables, right? We are using the ID that is referenced to get the intersection between them. Okay, so that's how you use the inner join. So let's move on to left join. But before we try use the left join, let's suppose that I have a new author, right? So select all from authors. Let's suppose that I have a new author. I'm going to insert the new author. So insert into authors, name, values, I don't know, John Doe. The name that you use when you don't know how which name you can use. Anyway, so let's insert this new author here. This new author is in our table, right? Can you see? But we didn't associate, we didn't reference this author to any book. We have this author stored in our table, but this author didn't write any book. We don't have any book written by this author in our database, but we have the author in our database. This is a situation that is pretty common, right? So in the moment that this author was inserted individually, because we have a table to store authors, it doesn't necessarily need to have written a book. Let's suppose that we want to answer the question, which authors have written books and which haven't, right? Let's write a query that shows all authors and their corresponding books. But if an author hasn't written a book, the book column will show null, right? So we are retrieving the authors and their books, but we are also going to see that some authors may not have written a book. They are going to show up in our output, but without any book, right? For this, we had to use the left join, because we're going to show every author, even if this author haven't written a book. And we're also showing the books by that authors. But when an author doesn't have a book, the book will not appear, right? So just for you to understand, we are retrieving data, searching for books by author, but we are in a situation where not necessarily every author that is stored in our table has written books, because we have a table just for the authors, even if they haven't written a book, or even if we don't have a book of this author stored in our books table. Can you get it? That's a situation. There's a situation. This is a situation where you use the left join. Okay, so select all authors.name as author. Let's give it an alias. Books.title as book, as we did before, from authors, right? If you run this, it's not gonna work, obviously, because the book title is not stored in the authors table. We have to join with the books table. But in this case, we want to prioritize the authors showing up in the result, in the output. So we used the left join. On authors.id equals books.authors. Sorry, I forgot to put the table here. Okay, so we are selecting the author and their books, the authors and their books. But as we know that not every author has a book stored in the books table, we are doing the left join to show the list of authors independently, the list of authors, even if they don't have a book stored and referenced. So I made a mistake. I made some mistake here. Let me see. Books, obviously, books author, no, books author, the column author, right? There you go. We have the author and the book, and even if the author doesn't have a book associated, referenced, we show up here as null, but the author is still here. We are selecting the authors and the books, even if the author doesn't have a book. Okay? I hope you understand this. So we can do pretty much the same thing, but by books. What if you want to know if there are any books without associated authors? We can do the same thing, right? So let's see the books we have. select from books. Here we have every book with an author, but let's insert another book, and let's insert a book without author, with no author associated, right? So insert into books, title, release, year, price, and let's not insert author. So values. Let me see. Harry Potter. You already have Harry Potter here? No. So Harry Potter. Released year, I don't really remember. I think it's year 2000. I don't know how to say this year exactly in English. But price, let's put $50, and let's insert it. It was inserted successfully, but if I select the books, I'm gonna see that this book doesn't have an author associated, right? So we can do a right join to see if there are any books without associated authors, and if these books, to see, in fact, to see all books, including any that don't have an associated author, just as we did, pretty much like as we did with the based on the authors, but in this case is going to be based on the book. All right, so let me change it back to our query, our left join query. Right, we have exactly the same structure, getting the author's name, getting the book title, right, from the authors. When we do this, authors is our left table, okay? The based table is in the left. So with the same structure, we can just change the output. Let me see. We can just invert the output if we do this right join. Can you see that? If we do the left join, we have the authors and the books, even if an author doesn't have a book. But if we do this right join, we have the books even if a book doesn't have an author. Can you see that? It's a pretty powerful way to filter data. Okay, so that's how you use the right join. The authors table is in the left because of this structure here. The books table is on the right. Then I can set what table is the base for the retrieving and the filtering, right? So if I do left join, I get the authors, even that authors that doesn't have a book. If I do the right join, I get the books even if the books doesn't have an author. Can you get it? I hope so, right? We can also combine both of them. Let's suppose you wanted both results in our result set, in our output. Let's suppose that you wanted to have every author, even if they don't have a book, and every book, even if they don't have an author. You can use the famous full author join. In this case, in MySQL, we are going to use the union clause. We are going to have an union from both results in our result set. Okay? So we can do the left join here, and we can do the right join here. Can you see that? Simple as that. I just copied and paste and change. But for using these two structures and putting it all together, I use the union keyword, right? So I have the authors, even if they don't have a book, and the books, even if they don't have an author. And I don't want to choose one or another to appear here. I want every single record that fits this parameter and matches this criteria. Alright, so let's run and see that now they're both here. This is the worldwide famous full author join, the legendary full author join, or in MySQL, the union. Okay, pretty simple. When you know the left join, the right join, it's pretty simple to use the full author join. So in our result set, we have every author, including that authors that doesn't have any book associated with them. But we also have every book, even if the books that don't have any author associated with them. Alright? So let's move on to the end of this class and understand how the cross join works. Right? So let's suppose you don't know, you don't really know, you couldn't think about the possible combinations of, for example, books and publishers, because there's many relations, right? Books and publishers is a many-to-many relationship. Books and publishers have many-to-many relationships, right? So I can't think about the possible combinations. I want to know. I want to produce, like I said before, a Cartesian product, right? Pairing every book with every publisher. So in this case, we can use the worldwide famous cross join. Okay, so we can select books, the title as book, publishers, that name as publisher, from books, our left table is going to be the books. But if we want to understand the possible combinations, to get the possible combinations, we just use the cross join with the table publishers, right? So what are the possible combinations? Getting the left table and the right table. So these are the possible combinations, not the relationship themselves, but the possible relationships, right? So when we relate the publishers and the books, every single publisher can publish every single book. So this will be the combination, right? Then we can have this amount of possibilities, right? Like 30 combinations. That's a good information to know. You're probably someday in your life using this, okay? Let's get things a little bit more complex. Let's answer one more question, okay? Just one more question to finish this class. Let's join multiple tables, because we use join, but we just joined 2 tables. Let's join 3 tables now to see how it goes, okay? So let's suppose I want to discover, retrieve which books were published by each publishers and who are the authors. That's a good way to retrieve data from 3 tables at once using joins. In fact, we can just use the inner join because we want to get an intersection between the 3 tables, right? So table books, table authors, and table publishers. We want to get the intersection between them. So let's write a statement to do this. So we're going to select books.title as book, we need to give the alias authors.name as author, obviously, as we did before. And in this case, we're going to get the publisher's name also, publishers dot name as publisher. All right, from books. All right. Now we have to get the data together. We have to do the joins. We are going to use the inner join, starting with the authors, because we want to know who are the authors from each book by each publisher, right? So inner join authors on books.author, table authors, column author, in table books, on table books, right? Equals authors id, authors.id. Okay, so in this first inner join that we're writing right now, we get the author ID from the table authors. We compare with the author ID in tables books to get who is the author of that book, okay? But let's move on. We have to put another inner join here. So let me give some space. Inner join book publishers on books.id equals book publishers dot book ID. All right. So here in the table book publishers, we are getting the book ID, where this book ID is equals, we are getting this book publisher ID, the book ID in the table book publishers, where this value, this ID, is equals to the ID of the book in the table books. There you go. And let's put another inner join here to get publishers on book publishers. Publisher ID, right? Publisher ID, where it equals the publishers.id. That's it. So in the table publishers, in the table book publishers, where the ID is equal the ID of the publishers table, we're joining everything and retrieving this beautiful thing right here. We just joined every table. We just used every table of our database to join data and give an output of data, a result set that has the book, the author, and the publisher. The publisher of the book, and who is the author of the book? We have the books, the author of the book, and the publisher of the book. Right? Why do we have just 4 books? Because in our table, we only have 4 books that has the relationship between the book and the publisher. Remember? In the table book publishers, we just related 4 books. So if we want to know who are the publishers of the book, obviously we're just retrieving the books that has publishers associated with them in the table book publishers, right? We are using this table to get this data. And then for the books that are published, that has publishers, we get the result, and we know, instead of just seeing this, that doesn't mean anything for humans, right? We can see this, and it means a lot for humans. The exact result set with the data that represents the books, their publishers, and their authors. Okay, so that's how joins work. I hope you like this class. I hope you understand. I hope you understood what I have taught you. And if you don't worry. You just need to practice, right? So create the tables, populate the tables, and start thinking about questions that you need to answer, retrieving data from all of these tables. All right? And this way, you're going to practice the skill, the ability of answering questions using queries. And in this case, pretty advanced queries, pretty powerful queries, not just simple queries like select from, but select specific columns, joining columns from other tables, and putting it all together to answer questions. All right, that's it for today.